This is section 5.2, and we're talking about logarithmic functions and their graphs. So what is a logarithmic function? Basically, just so you know, it is the inverse of an exponential function. So anything that has the form f of x equals a to the x, it will have an inverse, and that function would be log base a. So here we have, for any x value greater than 0 and a greater than 0, also a not equal to 1, you have log base a of x, if and only if x equals a to the y. So one of the things I wanted to point out to you on this is that if I wanted to convert, notice that this is the base here. A is always the base. Here, it's the base of the logarithm as well. And notice that the x and y are reversed. So literally, you're just switching places here. So if I wanted to convert this to log, I go a log base a of x. So I would just go kind of in clockwise order. Log base a of x equals y. So here's an example of that. We have 2 equals log base 3 of 9. So 3 is your base. So you're going to start with 3. 3 to the second equals 9. And that's what we have here. Same with this one. If I wanted to convert it back the other way, this is log 5. So you would say log 5 of 125 equals 3. And that's what we have here. So let's evaluate each one of these. And again, you need to ask yourself, 2 to the what power equals 32? So when you do that, you can guesstimate it on your calculator. 2 to the 5th is 32. So you would like 2 times 2 times 2 times 2 times 2 equals 32. If you happen to have a base 2 function on your calculator with a logarithm, you can actually just put it in your calculator. However, most calculators are in base 10, so you won't be able to just do it that way. So you're going to have to do some guessing and checking with these until you learn another way later in the chapter to find the answer. All right, so log of base 3 of 1, what is that equal to? Well, 3 to the what equals 1. Anytime you have a log equaling 1, that means it's going to be to the exponent of 0, because anything to the 0 power is 1. 4 to the what equals 2. Well, in this case, we're going to reduce this. So when you do that, it's going to be a half power, because a half power is the square root. So that would be 2. And then on this one, 10 to the what power equals 1/100th. So 10 to the second equals 100, but to become 1 over 100, it's going to have to be a negative exponent to do that. So some basic things that you need to remember when you're looking at logarithms is, again, all logarithms on a calculator are typically base 10. That's the common logarithmic function. And here's some basic things that you might want to put in your notes. Log base a of 1 is always 0. It doesn't matter what the a value is. It could be anything. So it's just basically, if you remember, anything to the 0 power is 1. So that is why 0 is the equivalent there. Log base a of a to the what power equals a? Well, that's always 1. And then if you have a base a to the x, basically those a's cancel out and you just have an x. And log base a of x equals log base a of y only if x and y are equal. So in that case, you can just get rid of the log base a's and just know that x equals y. That's called the one-to-one property. So a graph of a logarithmic function can look like this. We're going to look at both of these. First, I'm going to make a t-chart of the 2 to the x value graph. And you notice that the t-chart has from -2 to 3. And if you plug that in, you'll get 1/4, 1/2, 1, 2, 4, and 8. Now, here's the one thing I want to remind you is that the log function is always the inverse of this. So basically, to find the log function, you're going to switch your x and y's. So this would be your f of x on the top, and this would be your x on the bottom. So when you do that, you're going to get the inverse of each other. So I want to show you what that looks like. Notice that for x at -2, your value was at 1/4. Well, in the logarithmic function at 1/4 as your x value, you have a value of -2 for your y. So they're inverses of each other. So if you have to graph a logarithmic function by hand, I would first plug it in as a exponential function and then invert it with the x and the y's reversed. Okay, so some things that you need to pay attention to with log functions is notice that there's a vertical asymptote at the y-axis, which is x equals 0. And it always goes through this point 1, 0. So the domain starts at 0 and goes to infinity. The range is all possible values of y, so it would be -infinity to infinity. The intercept, again, is right here at 1, 0. It's increasing, and it's a 1-to-1 function, so it is an inverse. Now, notice, this is exactly the opposite of the exponential function. So here we had the domain of -infinity to infinity, but back here, it was a domain of 0 to infinity. And then it switches in the range 0 to infinity. Back here we had -infinity to infinity. The intercept here was 1, 0. Well, guess what? The intercept in the other one is 0, 1. So as you can see, they're opposites of each other. They're definitely inverses of each other.